Welcome back to this class. I hope you all are doing good. So let's understand about the discovery of cathode rays. So before discussing anything about cathode rays, let's discuss about cathode ray tube first. This was the instrument, that magical instrument that was used by many scientists to discover different subatomic particles like electrons and protons. And this consists of a glass tube in the middle, this one, and it is fitted with two electrodes, and these two electrodes are made up of either cesium alloy or iron alloy, and these two are connected to two terminals of a high voltage battery. The one which is connected to the negative terminal is called as cathode, is bearing negative charge, and the one that is connected to positive terminal is called as anode, and it is bearing positive charge. So all the air inside this glass tube, it has been taken out by using a vacuum pump and has been created a vacuum inside this tube. So the pressure has been reduced to as low as 0.01 millimeter of mercury. So this is very reduced pressure, and this has to be done in order to make the experiment run very smoothly, because the air particles will definitely produce resistance or may ionize in the experiment, and the results will be altogether different. So vacuum has been created. Vacuum क्या होता है? वो जगह जहाँ air भी ना हो, that's called vacuum. So वहाँ पे vacuum create किया गया inside the tube, और इसके अंदर गैस भरी गई. So most scientists used hydrogen gas at that time, hydrogen gas mostly, and the current was passed through that gas. So current as high as 10,000 volts was passed through this gas. Initially, gas is not conducting any current, but as the current increases or as the voltage increases across the electrodes, and the gas start in conducting the electricity or current. So this was the experiment, and that took place at that time and led to the discovery of electrons, protons. So who was the scientist who first performed the experiment of trying to conduct electricity through gases? He was none other than William Crook in 1979. So Crook was studying gases under very low pressure and high electric discharge. What he observed was, at high voltage about 10,000 volts and a pressure as low as 0.01 mm of Hg, gases start conducting electricity from cathode to anode. Okay, so gases start conducting electricity from cathode to anode. So from here to here, from cathode to anode, in the form of rays. So these were in the form of rays. So some rays were seen, or some rays were detected, we can say. So how the detection was made? Detection was made by using a fluorescent screen or fluorescent chemical, that is ZNS. At this end, inside of this end, at the cathodic end of the tube, the inside was painted with ZNS, zinc sulfide. Zinc sulfide. It is a screen which has a property of detecting particles or high charged particles when they strike on the screen. So this screen would produce flash. That flash is called as scintillation. So this is how a green flash was produced at the end, at the anodic end of this glass tube, or at the anodic end of this cathode ray tube. In this way, scientists were able to confirm that something or some particles are hitting on the zinc sulfide screen, and they are just coming out from the cathode. So it was like they are coming from cathode. So that's why they were known as cathode rays. Since they originated from cathode, they were named as cathode rays. Okay. So it's only that they were named as cathode rays because it seems that they originate from cathode. Now, William Crook could only study this much. So after this, a remarkable scientist named as J.J. Thomson came in, and he started replicating the same, and he further studied and he further tested these cathode rays, and then he found that particle. Okay, let's understand about discovery of electron by J.J. Thomson. In 1897, Joseph John Thomson studied characteristics of cathode rays. So when he started studying characteristics or properties of cathode rays, in that way he was able to figure out that cathode rays are made up of negative charged particles. So what he observed, J.J. Thomson performed this cathode ray experiment. What he observed, the first observation was these cathode rays are traveling in straight line from cathode to anode. Okay, so they are not bending anywhere, they are not curling anywhere, so they are traveling in just straight lines. Second observation was they produce greenish yellow fluorescence on the screen, and I have also mentioned that screen, that is ZNS, zinc sulfide screen. So whenever they hit the zinc sulfide screen, a greenish color fluorescence, means a greenish color flash, is produced at the end. Third observation was they get deflected towards the positive plate of external electric field, confirming these being negatively charged. Say for example, if we apply electric field across this tube, okay, so what he observed on applying electric field, so he observed that these cathode rays are bending towards the positive plate of the electric field, and they are bending away from the negative plate, means they are getting repelled from the negative plate of the electric field and they are bending towards the positive plate of the electric field, confirming that these cathode rays have the particle that carries a negative charge. Cathode rays cast a shadow of an opaque object coming in their way, they carry mass. That means if something is placed in the line of cathode rays or in the way of cathode rays, they will definitely produce a shadow of that object on the other opposite side. So if cathode rays are hitting this object, the shadow will be produced on the opposite end of that object. That means since they are not bending, okay, so that means whatever cathode rays are hitting the object along its length or breadth, so these cathode rays are being stopped. So on the other side, so no cathode rays are there on the other side, that will produce a shadow in that way. Since they are particle nature, cathode rays have mass, since particle is having a mass. One more observation, they cause ionization of gas they pass through. Now, moving forward, let's understand the conclusions drawn out from these observations. The first conclusion was cathode rays consist of negatively charged particles called as electrons. Okay, so how he was able to confirm that? Because of applying the electric field across the beam or across the glass tube. So in that way, these particles were seen to bend down towards the positive plate of the electric field. So that means conversely they contain negative charge, because positive and negative charge are getting attracted, and positive and positive charge may get repelled, or negative and negative charge may get repelled. Now, second observation and third observation says electrons are integral part of every atom. So whatever gas they were using, the same results were obtained. That means every sort of matter is made up of is containing electrons. Okay, so every sort of matter is having electrons in it. Electron has a definite charge and mass. Definitely electron has a definite charge and mass, and charge of an electron is 1.602 multiplied by 10 to the power minus 19 coulombs. This is the charge of an electron, and it is negative, minus 1.602 into 10 to the power minus 19 coulombs. After that, mass of an electron is 9.108 into 10 to the power minus 9.108 into 10 to the power minus 31 kgs. This is very, very small mass. Okay, this is it's very small mass. When you compare this mass with proton or neutron, you will analyze that this is very small mass. The charge by mass ratio, which is also called as specific charge, that is just the ratio of charge over mass. It's for electron, it is 1.76 into 10 to the power 11 coulomb per kg. This is called specific charge. And this specific charge always remains same irrespective of the gas in the glass tube. Whatever gas you are using in this glass tube, whether it is hydrogen gas, whether it is some other gas, okay. So this E by M ratio will always be same for electrons. That is 1.76 into 10 to the power 11 coulomb per kg. Why? Because every electron is having a charge exactly equal to minus 1.602 into 10 to the power minus 19 coulomb. It's not going to change, okay. And mass of an electron is also not going to be changed. These are two integral properties of electrons. So that's why every time you calculate E by M, it will always be same. Okay, so and this E by M value is not affected by the material of the electrode used. Okay, whether you use cesium alloy electrode or iron alloy electrode, so definitely this E by M is going to be same, because it does not depend upon the nature of the electrode as well. Okay, so every electrode, whatever you use, definitely has electrons. It will emit electrons, and electrons are having these two integral properties, and their division is always giving the same result. That is E by M is equal to 1.76 into 10 to the power 11 coulomb per kg. Okay, this was about discovery of electron. Now let's move ahead. Look at this. Say for example, if we apply electric field across this glass tube, So these cathode rays will bend towards positive plate of the cathode, and they will bend away from the negative plate of the electric field. Okay, so this confirms the negative nature or negative particle of the cathode rays. Okay, great. Now move ahead. Discovery of proton by Goldstein. Look at this. So at this time, the polarity will be reversed. Look at this. In the first experiment, we were having cathode at this place, but this time it is anode. Polarity have been reversed. So Goldstein performed the same experiment with reverse polarity, and he figured out that in 1886, he noticed that another set of rays traveling from anode to cathode. This time it is reverse. From anode to cathode. Okay, from positive plate to negative plate. He called these anode rays because it seems to be originating from anode. Or he also called them canal rays. Why? Because they were allowed to pass through the perforated cathode. Perforated cathode means having holes in it. Having small holes in it, perforation is there. So these anode rays were traveling through these pores which are there in the cathode. So then they hit on the zinc sulfide screen. So that's why they were also called as canal rays. Okay, canal for a hole. Now, what were the properties of these anode rays? Much they have the much similar properties as that of the cathode rays, but with some other properties as well. Now let's understand the properties of anode rays. First, in the same way, they travel in straight lines, just like cathode rays. Second, they have mass and produce mechanical effect. Okay, mechanical effect means whatever object is placed in their path, they will try to move that object, and that object will move. Okay, from one place to another place. That means they have a mechanical effect. Okay, so this was confirmed by placing a small fan. Okay, a little fan was placed inside the tube, and this fan, the blade of these fans start moving when they were hit by anode rays. Okay, so this fan start moving. A little fan. This fan starts moving, so that's how they confirm the mechanical effect of this anode rays. Now they contain positive charged particle, and they called it proton. Okay, they show deflection towards negative plate of the external electric field, confirming their positive charge. So on contrary to the cathode rays, these rays, which were anode rays, they deflect towards the negative plate of the external electric field. Okay, so if we apply electric field across this tube, and these anode rays will get attracted towards the negative plate of the electric field. So they bend towards the negative plate. And this is how they confirm the positive nature of anode rays. Now E by M. The E by M changes from gas to gas because atomic mass of different gases is different. So if you try to check out E by M for proton, for that you need to charge of a proton that's exactly equal to charge of an electron or charge of a cathode ray. So that is, but it is positive time is 1.602 into 10 to the power minus 19 coulomb. But mass, every time mass of an atom is changing. Whenever you use, suppose, hydrogen gas, the mass of hydrogen gas, that will be just 2 grams, or we can say 2 units. But if you change this hydrogen gas with oxygen gas, that is having a different mass. So every time mass of the particle will change when you change the gas. So that means the E by M of proton is always changing because of different masses of different gases, or different masses of atoms of different gases. Okay, so this will always change. Now E by M for hydrogen gas is the maximum, because why? Because the mass of the hydrogen gas is smallest, so that's why E by M will come out to be maximum. E by M of hydrogen gas is maximum because H2 gas produces lightest proton on ionization. Okay, so E by M is directly proportional to charge of proton and inversely proportional to mass of proton produced. Okay, so in that way, every time a proton is getting generated having different mass when we use different gases, but the lightest proton is produced by hydrogen gas. Lightest proton is produced by hydrogen gas, so that's why the E by M will have a maximum value in case of hydrogen gas. Okay, as the mass increases, the E by M value will decrease. charge equal and opposite to electron. So charge of a proton is just opposite to that of an electron. If electron is having minus times 1.602 into 10 to the power minus 19 coulomb, the proton will have positive times the same charge. Okay, so that's written over here. And the mass of a proton is 1.672 into 10 to the power minus 27 kgs. Okay, so mass of a proton is much, much higher than that of mass of an electron. So proton is having almost 2000, it's 1837 times heavier than an electron. So proton is 1837 times heavier than an electron. So proton is found inside the nucleus, whereas electron is found outside the nucleus, revolving around the protons. Okay, so proton is found inside the nucleus of an atom. Now this was about discovery of proton by Goldstein. If you have any kind of doubt, you can post that in the comment box. So we are moving ahead. Anode rays produce fluorescence on zinc sulfide screen. Yes, we know that. Anode rays produce fluorescence. That is the flash, okay, green flash on the zinc sulfide screen, which is coated just after this perforated cathode. Okay, so after this, on the screen, inside of the screen, there is zinc sulfide that's coated on it. So whenever a anode or whenever a proton hits on this zinc sulfide screen, it produces scintillation, or it produces flash, confirming that a proton has hit on that screen. Okay, so this is how they were detected. Now if we apply electric field across this across anode rays, so they deflect towards the, look at this, they deflect towards the negative end of the electric field, confirming their positive nature. Okay, confirming their positive nature. Okay, discovery of neutron by James Chadwick. In 1932, James Chadwick bombarded light nuclei such as beryllium nuclei with alpha particles. Okay, so alpha particle is just helium nucleus. Say we have helium atom, atomic number 2, mass number 4. So we just remove 2 electrons from helium atom. So it is left with only 2 protons inside its nucleus, okay, and with a mass number equal to 4 because of 2 protons and 2 neutrons. There are no electrons inside this helium nucleus, which is also called as alpha particle. Okay, so denoted as alpha particle. Okay, so make yourself much comfortable with alpha particles, because these are also used in Rutherford's model, atomic model. So Rutherford's experiment, we can say, in that experiment alpha particles played a great role. So the equation or the reaction is, this is a nuclear reaction. Whenever nucleus involved in the reaction, that's nuclear reaction. Okay, so this is beryllium, atomic number 4, mass number 9. It is hit by an alpha particle. So this alpha particle changes the nucleus of a beryllium into some other element, which is carbon. Carbon is having 6 protons, 6 electrons, and 6 neutrons. In that way, 1 neutron has been lost from this reaction. When this neutron is lost, this neutron is being detected by a detector, confirming that a neutron or a particle has been removed from an atom or from nucleus of an atom. Then neutrons were tested against an electric field and magnetic field and all that, but surprisingly they did not get deflected either ways. That means neutrons are neutral. They do not carry any charge, no positive charge, no negative charge. Okay, so this 0 at the subscript indicates its charge, and this 1 indicates its mass on the superscript. Neutrons are present in the nucleus of all the atoms except hydrogen. Okay, every atom contains neutrons in its nucleus. So every atom in its nucleus contains these neutrons or neutral particles, but hydrogen do not have any neutron. So hydrogen nuclei is with 1 proton and nothing else. Outside is just 1 electron revolving around it. Okay, so this is how hydrogen atom look like. So this may be asked in your examination, that which of the following does not carry neutrons. So you must be able to understand that that's only hydrogen. That's why whenever hydrogen atom loses electron, we call it proton only. Okay, so that's why, because its nucleus is containing proton only. That's why the name is there. Neutron does not show any deflection in magnetic or electric fields, confirming it is a neutral subatomic particle. So there is no deflection. It passes straight through the electric field and magnetic field, so confirming it does not have any charge. but mass of the neutron is a bit heavier than, slightly more than proton. The value is 1.676 into 10 to the power minus 24 grams, or you can convert it to kg as well, 1.676 into 10 to the power minus 27 kgs. Okay, so this is how it looks like. Now let's have a comparison of all the three subatomic particles, electrons, protons, and neutrons. Electron have a mass 9.108 into 10 to the power minus 31 kgs. Electron has a charge of negative 1.602 into 10 to the power minus 19 coulombs, and E by m of electron, which is a constant, is 1.76 into 10 to the power 11 coulomb per kg. Proton mass is 1.672 into 10 to the power minus 27 kgs. If you compare electron with proton, you can see that it's minus 31, it's minus 27. So proton is almost 2000 times heavier than electron. Proton is 2000 times heavier than electron. The charge of proton is positive times 1.602 into 10 to the power minus 19 coulomb. Neutron 1.676 into 10 to the power minus 27 kg. That's the mass. Compare it with the mass of proton, you will see that it's slightly heavier. Neutron is slightly heavier. It's 1.672, but it's 1.676. So it's slightly heavier than proton. Okay. And neutron does not carry any charge. No charge is there. So this was about all the subatomic particles, their discoveries, the experiments used, and the methods that they employed to discover electron, proton, and neutron. And if you have any kind of doubt or any sort of question, please drop that in the comment section. I'll make sure to answer that on time. Take care, bye-bye, and see you in the next one.